Okay, so now let's start talking about mechanism. So we're going to start with a small overview with a basic mechanism. So if you go in RoboDK utilities and then model mechanism or robot, just like that here, you will have access to this window here. So this window will let you do a lot of things, including creating custom mechanisms, obviously. So you can create many types of mechanism through that window. So I'm gonna just make that a bit bigger for you guys. So the first type of mechanism or that you can create is a simple rotative axis. So it can be used if you want to animate a welding gripper like that, or if you want to animate a turntable. So in both cases, rotative axis would be the right choice. You can go for two rotative axis if you have a positioner like the DKP from KUKA. That would be one thing. You have a linear axis if you're trying to create a linear rail, but also the same if you're trying to create a conveyor or any sliding motion, because it can be a door, let's say. You can create two axis T-butts, so you have a kind of a small gantry, two axis gantry, where you can move around X and Y. You can go for linear rail with on top of it a turntable, so two rotation. You can go for a two-finger gripper, just like that, so that it is really animated, not just show and hide. You have three-axis robots, so a H-bot or a gantry, so X, Y, Z. You can create four-axis scatter robot if you want, with rotation, and then rotation and prismatic motion. You can do the four-axis scatter robot, but the other way around, with this one being the prismatic motion. You can create your own six-axis robot if you want. That's super easy to do. This is the method that we use to create our robot in the library. You have the six-axis collaborative robot that you can create, so UR, TM, OBO, and other of that liking. And you can create seven-axis industrial robot. Like here we have the KUKA EVA. So this this environment here is super helpful. It's kind of a step-by-step situation. So if you want to create a one rotative axis mechanism like this one, you simply select this one, you go enter a name. Most of the time you won't have anything to do here, but I'm going to explain you what this does. Then you'll have to select one reference frame. You'll have the object, so in this case it's as we have a rotative object, you have one object that is static, so the base, and one object that is moving, joint 1. You will be able to tell the home position, the minimum and maximum limits, and in which direction you want the joint to rotate. So fairly easy. And here behind me you have update, OK, and cancel. Update will be your friend as much as possible. You're only clicking on OK once you are sure and satisfied that what you created is what you need. Otherwise, you're just updating in the process. So here I just want a quick look on those two here. Most likely you won't have to play with those, but I just wanted you to know what they do exactly. So this is a base shift. So this is in what direction will the rotation occur. If you don't change any of those here, you just have to look at the images here. So if you were to create that welding grip, I don't know how to call that, but anyway, welding tool, so for spot welding, you would simply put your reference frame right here to have a rotation around the Z axis. If you were to create a turntable, you would put your reference frame right in the middle here to do a rotation around the Z axis. So if you do exactly like in the picture here, you have nothing to change here. On the contrary, if you decide to have it elsewhere in another direction, you need to compensate for that discrepancy between the image here and what you really have by applying some translation. I would only recommend doing so if you know how transformation metrics work and if you kind of know how RoboDK works, because I wouldn't recommend doing that like if you're just a newcomer to the software. That's kind of a added complexity that you don't necessarily need. Same here for the end effector. So this is between the base and the first joint, and then this is from the joint to the last end effector or TCP of the robot, or flange of the robot, in fact. Okay, so we'll start with the next video by doing a linear RL, and then we'll cover the different type of mechanisms one by one.